So we're going to talk about random variables really quick. And if you, I don't know if you want to snap a picture of this with your phone, so you don't have to write it all down right now. It's up to you. But the biggest, I think the most helpful thing to do today would just to be go through questions. Okay, so if you have a sheet of paper out and a piece of paper, and if you are watching from home, I would encourage you to pause before the question, or when I put the question up there, and then do the problem, and then I will explain it, and we'll kind of, as a group here, we'll kind of go through it together, or you can try it on your own as well. A couple of things really quick. The expected value, I have the formula sheet up here, I believe. You want to make sure that for expected value, you are showing your work. So expected value usually will have some sort of problem about observations. And they will either give you the probability of the observations or you have to find it. And just remember then your table looks like this. And you have to show your work. So for expected value, you'll notice some keyword about how much can you expect, okay? Or find the average of the the average of the probability distribution. And again, forgive me that the printer didn't work, okay? So the average of the probability distribution. So like I said, they'll either give you a table. So they might say, hey, your observation is 2, 8, and 10. And then they'll give you the probabilities, or you have to find it based on the situation. So 0.1, let's say 0.3, 0.6. Now it's easy to do this in your calculator. So if you have your calculator now, you can quickly put it in if you want. At home, pause it right now. And what you're going to want to do is you want to enter L1 into your observations and then L2 into the probability of your observations. So I'll give you a second to do that. Yep, it's just easy to do those three. Just a quick calculator reminder. How many what? I haven't looked on these. I get a bit on my Algebra 2 videos that I make. I don't really like push it. So, you know, some people like push their whatever social media they do. I don't push it too much. So, and I kind of just started doing it this year and last year. So hopefully it will get bigger because I think it can be useful. Next year though, did I tell you guys what I got? It's so I don't have to wear this thinking thing. I have this globe and it just picks up my voice from anywhere in the room. Yeah, so I could just like, yeah, kind of, yeah. So, what? I think it would, like, if I keep it at the desk, it would pick up mine, and then I think it would pick up others, and there's probably good and bad about that, but the good would be, let's say there's a question, so real time it would pick up, you know, because I think people who flip the classrooms, sometimes you miss that real time questioning that's happening, so it could get that and kind of create that a little bit more. And the sole purpose would not be to flip the classroom, but just to have those extra videos out there for people. Okay, so when I have this in my calculator, how you want to put that in, you should have L1 and L2. And then what you want to do from there is you want to go to one variable stats. And you want to hit enter. If you have the old calculator, you want to put L1, comma L2. If you have the new calculator, it should say like your list. And then it would say X list, I believe. Let's see what you guys have here. Nope, now you want to go to calculate one variable stats, hit enter on one. Okay, so you have the new calculator here. So list would be L1, and then frequency list, you want L2. And then the big thing is you want to clear that out after you do it because you don't want to keep it on L2 or when you're doing a one variable stats, it might keep doing that. Okay, so where are we at here? The X bar right there, that's your 8.6 for this one. So you would say the expected value. is 8.6. Now the AP exam will not accept that as a value. To them, you're just plugging and chugging. You don't really know what you're doing. So you have to actually follow the formula here. And just a friendly reminder, this sigma, do you remember what that means? That means summation. Xi right here, that means the observation, your first observation, say, P of I, the probability of your first observation. So I take right here my observation times the probability of my observation. 2 times 0.1 plus, again, my next observation, 8 times 0.3 plus my next observation, 10 times 0.6. That's that right, Eric. So if there's a lot of observations there, let's say it went to 12, 14, 16, 18, take the first observation times the probability of the first observation plus ... the last observation times the probability of the last observation. So in this case, even though there's 3, it would look like this. That's enough work to show your expected value. You do need to show your work for standard deviation as well. Now you'll notice they don't give the standard deviation, okay? Before I start talking about the standard deviation, look this over. Do you guys have any questions about the calculator use or showing your work? Okay, so the next thing here then would be the variance of a probability distribution. Right here, this xi, that's my observation. This mu of x, look here, it matches that right there. That's my expected value. And then P of I, this is your probability of the observation. Now your variance is your standard deviation squared. So how would I get my standard deviation if I know my standard deviation squared? Yeah, I need to take the square root. Here's how I show my work. Okay, and we're going to use the same data that we have there in the black, the 2, 8, and 10. I'll give you a second because some of you are writing stuff down. This one right here, this P of I is the probability of the observation that you're looking at. All right, so what we're doing now is we're going to find the standard deviation of that probability distribution. That's the goal, okay? So what we need to do is we look at here and we follow along. The first one we see is that observation. So I take my first observation I see, which is what? 2, yeah, very good, okay? Minus the mu of x, which is, we already said it here, is your expected value. So minus 8.6 squared times the probability of that observation. And the observation we're looking at is 2. And the probability of that observation we said was 0.1. So if you look up here, right? So those are the numbers we're working with, as well as our expected value of 8.6. So I'm going to multiply that by 0.1. And now I am going to do the ... because it's a lot of plugging in. And I'm going to do the last observation. And so my last observation then, xi. Yep, that's a good question. That's right here. I'm going to highlight just so we can see. Give me a second. Let's use green. It's right here, that mu of x, that's your expected value. Okay, and so you can see here, this 2, that's there, that's my observation. Okay, are we good with the probability then? So I'll kind of match it up with colors. Let's see, what's the last thing there? Okay, do you see where that all matches up now? Okay. 8.6 is the expected value for, no, it's the expected value for the whole distribution. Okay, so for this entire observation right here, 8.6 is the expected value. And you can see it is the mu of x right here, okay, which is the same thing right there. So I always find my expected value first. And then if they ask you to find the standard deviation, this calculator is going to give it to you again. You just have to be able to use this formula and plug it in. Okay, are we okay? Are we tired? Are we okay? Okay. Yeah, that's 0.1. Let me erase it just because it looks bad. I don't want you to think it's like, I was just trying to match it up for you. So, okay, so I have 0.1. Okay, so again, this is my first observation. This is my expected value. And this is the probability of the first observation. So the probability of 2. Squared. 0.3. Yeah. And then plus the last one. So the last observation would be 10. And I'm going to skip that middle observation just because it is plugging in so many numbers. 10. So that's my last observation right here, right? Minus 8.6, my expected value, squared, times the probability of 10, so 0.6. And then in your calculator, it gives you the standard deviation. So if you just hit on, you'll see it. It's the sigma there, 2.37. Questions there on just the calculator piece and how to plug it into our formula. Normally they're going to want probably 3 to 4. So I think just because we're kind of cruising through things, but we should probably put that. So 2.374. I actually tell my students to do 4. All right, you ready to try some problems now? Some like actual problems? Okay, all right, let's do it. So the first one, do you guys want to try it on your own or should we just do it together? Try it on your own? Okay, so I'll read through it with you. The random variable x is normally distributed with a mean of 5 and a standard deviation of 25. The random variable y is defined by y is equal to 2 plus 4x. What are the mean and the standard deviation of y? So I'll pause it right now at home, then you should do this, and then the people in here, why don't we do this now? Okay, so this is combining variables. This is actually not too bad. It's dealing with the transformation of data that we have. So there was some list of data where the data, and they got the mean of 5 and the standard deviation of 25, okay? And now it's going through this linear transformation. And this is where you need to remember when we're dealing with linear transformations, okay? The center is affected by multiplication, division, and addition, subtraction, okay? The standard deviation is only affected by what? Addition, yeah. And just like a little review for you, if I just had 3 numbers, 1, 2, and 3, right? And if I added 5 to them, okay, I would be up at 6, 7, and 8. Nothing changed with the spread. But the center is still, the center did move up by 5, right? So the center added 5, all the positions added 5, but the spread is still the same. The range, 3 minus 1 is 2, 8 minus 6 is 2. So the big thing you want to write down is like your little laundry list, addition or subtraction. It doesn't affect spread when you're doing a linear transformation. Yeah, so that would be with scatter plots. All right, so the question was, will we deal with nonlinear transformations? And that's with scatter plots when you're doing like the log of y, okay? And we'll review that later, not today though. Okay, if I had 1, 2, and 3, and I decided to multiply all of these, right? So again, this is just a laundry list. This isn't even talking about number 12, but just some background information. So 1, 2, and 3, let's say I decided to multiply the data by 2, okay, and add 1. So if I multiply 1 by 2, that's 2 plus 1. That gets me, or let's do 2. I'm going to change it just because I don't want to stay in the same spot here. Let's say 3, okay? I take my data. So I take 1, right? I multiply it by 2. 1 times 2 is 2. 2 plus 3 is 5. So this data right here, this x now moved right here to the 5, right? Now 2 2 times 2, right? 2 times 2 is 4. 4 plus 3 is 7. So this one just moved right here. Okay, and then 3 times 2 is 6. 6 plus 3 is 9. So you can see here that not only, right, the spread is still the same here, but here the spread also was affected by that multiplication. Okay, the spread is affected by multiplication. It is not affected by addition. Okay, so what does that mean then? I take my mean, the mean of 5, the center's always affected. It's affected by multiplication and addition, okay? The spread is only affected by what? Oh, now I'm messing it up, sorry. The spread also changed, right? So the spread is affected by multiplication. The center is affected by multiplication. Addition only changes the center. It does not affect the spread. Are we okay? Let me write it out. I have it written out okay here. If I'm going to multiply or divide, this affects center and spread. So how do I apply it to this problem? The center's the mean. So what's going to happen to the mean? I'm going to multiply it by 4 and then do what? Add 2 because the center is affected by addition. Right? So what's my new mean going to be? My new mean is going to be 22, so I know I can cross off A and B. My standard deviation is 25. So what am I going to do with my standard deviation? I'm going to multiply by 4. Can I add 2 to it? No. Okay, very good. So what's my answer? D. Are we okay? You guys are looking at me a little confused. You okay, Lizzie? Okay. You okay? All right, let's move on. A nonprofit organization plans to hold a raffle to raise funds for its operations. A total of 1,000 raffle tickets will be sold for $1 each. After all the tickets are sold, one ticket will be selected at random and its owner will receive $50. The expected value for the net gain for each ticket is negative 0.95. What is the meaning of expected value in this context? A, the ticket owners lose on average 5 cents per raffle ticket. B, the owners lose an average of 95 cents per raffle ticket. Each ticket owner will lose 95 cents per raffle ticket. A ticket owner would have to purchase 19 more tickets for the expected value of his or her net gain to increase $0. A ticket owner has a 95% chance of having a ticket that is not selected. What do we think? We know right away that wouldn't it be what? It is B. We know right away that expected value is an average. So immediately, what can we cross off? C, D, and E. There's nothing even about average in there, okay? The net gain on his ticket is 95 cents, which means he's what? Negative 95 cents. He's losing money per ticket in the long run. Questions? Feel okay about that one? Yeah. Okay. Next, thank you. Probability questions, you can just read through this. I think we should just get straight to the problems. Would you guys agree? Okay. Normal calculations, same thing. All right, the distribution of monthly rent for one bedroom apartment is in a city is approximately normal.
Dorian Jarno, please report to the main office. Dorian Jarno, please report to the main office. We have a very important message for you. Thank you.
All right, with a mean of $936 and a standard deviation of 61, a helpful hint on the test right away when you see the word normal and you see mean and 61, yeah, put it on a curve. Okay, so I'm going to put mean as 936. Standard deviation is 61. A graduate student is looking for a one-bedroom apartment and wants to pay no more than $800 in a monthly rent. Yep, 800 to the left. Very good. Okay, which is the best estimate of the percent of one-bedroom apartments in the city that a monthly rent of at most 800. Why is that at most important? Well, it tells us which way to shade. So at most, which way? Yeah, I'm going to shade left. So I actually don't have to subtract my p-value from 1. Okay, so I need to find my z-score first. And what do we get our z-score to be? 2.22. And then I'm going to go to my chart. I personally like the chart. I think Mr. Jans maybe taught you guys with the calculator. Okay, so the charts, here, does someone have their chart? You know what, actually, I think I put, is this a negative? Did you guys get a negative? You should have gotten a negative. Yeah, okay. I think you accidentally subtracted it wrong then. And how do I know it should be negative, guys? Yeah, it's on the left here. So your z-score in the center is 0. So it's on the left. So that would just be a good check for you. It's okay. I actually planned for it. I forgot that I did that. So I have negative 2.2 here. So if you don't know how to read the chart, just a friendly reminder how to read the chart. You look at your z-score chart. This is the only chart that I use a ton. I look at my z-score chart. These first ones are the first 2 digits of the z-score. And then right here is the last digit. So if I have a z-score of negative 2.22, I go and I look at my first 2 digits as negative 2.2. So negative 2.2 is right here. My last digit is 2. My last digit's here, right? So I'm looking at this row and this column, and they intersect right here. Does that make sense? Okay, so at 0.0132. So going back to the problem, what's our answer? If the p-value for this is 0.0132, the correct answer is A. Does that feel reasonable? Like, yeah, I can do that one. Well, if it's under 5% and it happens, we're suspicious. We're suspicious of the null hypothesis or the center of the distribution. And that's for significance tests. Yep. All right, ready to try another one? You guys want to just keep cruising through some? I think the best one with probability is just keep cruising. All right. Next one, a producer supplier ships boxes of produce to individual customers. The distribution of weights of boxes approximately normal. Again, with a mean of 36 pounds and a standard deviation of 4. Which expression represents the weight in pounds at the 75th percentile of the distribution? Okay, so what does that mean? That's 75th percentile. Yeah, we're on the right, okay? You can pick an arbitrary point. It doesn't matter. And a percentile always means less than by definition. So that means that this area here is 0.75. Well, the question is asking what's the observation? So I need to figure out what X is. Close, very close, Eric. That's very good. What we have to do is we have to find the z-score for 0.75. I don't have the chart, and if you guys don't have your charts with you, let me just show you with a different number. So I only have this for my chart. Let's pretend we needed a z-score for 5%. So a z-score for 5%, I would look between these two values here, 0.0505 and 0.0495. Which one's closer to 5%? Yeah, they're right in the middle, right? Okay, so the z-score that goes with it, if I go backwards, is negative 1.6. I'm going to go up, and in between these two would be 4, 5. Okay, Lizzie found her thing. So we're going to look for 75%. We're going to look for 0.75. And the closest one to 0.75.
0.7517.
Is that one closer? That one's closer, I think. 0.67. So a z-score of 0.67 gives us a percentile of 75th percent. Okay. And now I know what my z-score formula is. My z-score is my observation, so x, minus my mean, divided by my standard deviation. And now I know what my z-score is. It's actually 0.67. I need to know what the observation that is. Little algebra. And which one is it going to be? Well, look, though. It'd be D. It's the, yeah. So, and you can like confirm that by just saying, okay, a little bit of algebra here. I need to get rid of the 4. Okay, so 4 times 0.67 is equal to x minus 36. And then I need to add the 36. So 4 times 0.67 plus 36. And you can see it's D. So the probability questions that will go with the normal calculation will be both of these, where you have an observation, you find a z-score, you go to the chart, or it will be backwards like this one here, where you have the percentile or the probability, you find the z-score and you use algebra to solve for x. All right, ready to move on? Another problem? Can you guys hang in there for a few more? All right, you let me know when you're ready to be done. The commuting time for a student to travel from home to college campus, again, it's normally distributed. You're going to see a lot of those with a mean of 30 minutes and a standard deviation of 5. If a student leaves home at 8:25, what is the probability the student will arrive at college campus later than 9 a.m.? Okay, so right now we're in minutes, right? How is this problem different than what we've done so far? What's like the little extra step or the way they're kind of not really, yeah, what do I have to do? Yeah, I have to figure out the time. So 8:25 to 9 a.m., what's the time? 35 minutes. So where am I going to mark that? I'm going to mark it on the right. Do you want to do it or did we do enough for you feel comfortable? Close. Observation, it's ZOM. So that's my acronym for my class. Your observation, so this is the observed effect right here. Okay, minus the mean, so O minus M, observation minus the mean, divided by my standard deviation. Right, this Z right here? Right here? I don't know, your Z score is observation minus mean divided by standard deviation. Time, yeah, your T score is observation minus mean divided by, is your Z score 1? Okay, so 35 minus 30 divided by 5. Your z-score is 1.00. So you go to your chart then. It's point what? Okay, so Lizzie found the z-score of 1.00. Okay. Oh, it's messy. Is that okay? Okay. You found a p-value of 0.84, was it? Now, 0.84 is up there, but that's not the correct answer. It's 1 minus. And why is it 1 minus? Yeah, it's to the right. It's the campus later than 9 a.m. So that's this area here. And so that's where they're not trying to trick you there, but they're trying to separate who really is reading the question and who isn't. Okay. So the final answer would be what, guys? Yeah, 0.16. Very good. And why again? We need to do 1 minus 0.84. Our chart only does this area here. This is 0.84. And that's why we do 1 minus 0.84 to give us 0.16. Okay, another one?
Yeah.
Yes, I love the enthusiasm. Just one more.
2 more.
That's okay. That's okay. Let's do this one here. The probabilities of failure for each component in any one year are 0.01, 0.03, and 0.04 respectively. If any one component fails, the device will fail. If the components fail independently of one another, what is the probability that the device will not fail in 1 year? What? Yeah, so think of it this way as a reminder when you have a sequence of events, okay? You can multiply. In order for these not to fail, we need A to work and we need B to work and we need C to work. Well, if we know A is going to fail is 0.01, what's the probability that it will work? 0.0, yeah, 0.0, I'm sorry, 0.99. How did I get that from people at home who might be watching? How do I know it's 0.99? Well, if it's 0.01, it's going to fail. 0.99, they have to add up to 1. It's not going to fail. 0.03, what is it going to be for B? 0.97, yeah. And then here, 0. What? 0.96. I know it's tricky, but good job. Okay, we multiply that together, and what do we get? There you go. D. Check. See. So the question was just asked, can we multiply 0.01 times 0.03 times 0.04 and subtract from 1? What did you get? Yeah, and why is that? There's a key in there. It says if one component fails, all of it fails, okay? So that's why when you multiply these together, that's just saying all of them are failing. But you can also have the option of doing 2 of them failing or 3 of them fail, so on and so forth, okay? This one's not too bad. Should we do this one? Okay, I'm going to keep you here as long as I can, but I have to go soon, so we won't be too much longer. As part of a study on the relationship between the use of tanning booths and the occurrence of skin cancer, researchers reviewed the medical records of 1,436 people. The table below summarizes tanning booth use for people in the study who did and did not have skin cancer. Of the people in the study who had skin cancer, what fraction used tanning booth? There's a key word here. What is the key word right away? This is a given statement. And I'm not sure if Mr. Jantz had it this way. I'm sure he probably did. But what I said is when you're given a given condition, okay, this is conditional probability with a two-way table. When you have a given situation, do you guys remember? I don't know if Lizzie was with me yet. Eric, do you remember what I said to do to the given in a two-way table? Close, you want to circle the given. So we're only dealing with people right now who had skin cancer. So these are the only numbers I care about. Yeah, so the answer is B. It's 190 out of 196. So that would be like your little laundry list if you needed to write something down. When you have a given and you have a two-way table, circle the given. Those are the numbers you're dealing with. Okay. Questions? All right. Let's finish with 22. Oh, there's so many good ones, you guys. I could go on and on. Let's do 22 and then this one, and then we can be done. The next session, if you're going to stay after Thursday, I'm going to go through, I have a nice binomial distribution problems, and they're all problems to work on. So that can be one that kind of gets people as well. So that will be the next session that I'll talk about that stuff. Let's finish these problems though. So we're going to do this one. Let's just start with this one. A check of dorm rooms on large college campus revealed 38% had refrigerators, 52 had TVs, and 21 had both TV and refrigerator. When you see the word both, circle it. Usually, not always, when you see the word both, you're going to make a Venn diagram. Okay, and in the Venn diagram, right away in the center, you're always going to put the both. Okay, so 21% is right in the center, so 0.21. Now you can label it either way you want, but we'll just start here and we'll say the first one's refrigerators. So I'll label that R, and then the other one is TVs. Now what do I know? Well, I know that, exactly, very good. 52% of this, everyone had TVs. So this whole circle has to equal 52%. So I need to do what? Yeah, I need to take 0.52 minus 0.21, and I get 31 right here. And then if I look at the other side for refrigerators, right? Refrigerators is 38%, the whole circle, and so I need to do 0.38 minus 0.21, and I get 0.17. And then the question is, what's the probability that a randomly selected dorm room has a TV or a refrigerator, but not both? What would the answer be? 0.48, right? So you take 0.31 plus 0.17, but not both. Okay, we okay there? Now I'm going to do one more, and the only one I didn't get to that I would have liked to do would be a tree diagram. So that's one thing you're going to want to look at as well. Let's do this one. This comes from a released exam. So the faces of a four-sided fair die are numbered 1 through 4 respectively. For a certain game, the die is tossed and the number that lands face down is recorded. The table below summarizes the points a player earns for the number that lands face down. Consider the two independent tosses of the die. Let the random variable S represent the sum of the points earned. So you're throwing two tosses, right? And whatever lands, you get the sum of that based on these points. Okay, which table represents the probability distribution for S? So S is dealing with the sum, not what you're landing, so the sum of the points. What would be your strategy? Do you know? And I'm not giving you a ton of time to think here, only because we're recording and time is limited. But do you have any ideas what you might do? It's okay. We know that we're tossing two dice, so automatically I would say, hey, I would do, or it's a four-sided die, right? So I'm going to put 1, 2, 3, 4 for my first side. 1, 2, 3, 4 for my second one. Okay. So this, my red is one die, my blue is the other one. And then I'm going to go through and I'm going to figure out the points. Okay. That's going to go all in here. So if I roll a 1 and a 1, I get 0 points. A 1 and a 2, I get 1, right? What do I get here? A 1, 0, 2. And that's going to be the same going this way, right? If I roll a 2 and a 2, I get 2 points. A 2 and a 3, I get 1 point. A 2 and a 4, I get 3 points. Keep going. What? 2 right here? 1. No, a 3 and a 3, I'm going to get 0, right? Right, okay, and then a 3 and a 4. Oh, okay. So for a 3 and a 2, we would get 1 point. For a 4 and a 2, I'm going to get 3 points. A 4 and a 3, I'm going to get 2 points. And a 4 and a 4, I'm going to get 4 points. All right, so we need to look at the purple. That's what we care about. That's what the distribution of S is. So right away, what can I cross off for my answers? If the distribution is about the points that I'm getting, not necessarily like what is landing with my dice. I can cross off the top 3. Why can I cross off the top 3? Yeah, these S's are my points, right? Okay, so 0, 1, 2 is missing 4 and a 3-pointer. 0, 2, 4 is missing a 1 and a 3-pointer. And 0, 2, 4 again is missing a 1 and a 3-pointer. Okay, now we just have to decide between D and E. You can note that we have a total here of 16 observations. How many of them are 0 of my purple? I have 4 out of 16 are, so right away you can see that it's D, and you can just confirm it by doing a couple more. There are 4 ones, right? 1, 2, 3, 4 out of total 16 observations. So again, and you can just keep going down the line. All right. Let's be done. And then know that on Thursday after school, I'll do binomial and geometric distributions. And then the next week, I think we'll just re-go over inference. So any other questions? All right. I hope it